widen your focus from a narrow defensive protection of berries during harvest to being proactive, minimizing SWD in the landscape throughout the seasons. Once they lay eggs in the spring, remember, the numbers will increase exponentially after a few generations of buildup. I thought I'd begin by telling you a little bit about the general trend, particularly in this area of the Pacific Northwest, and how important this window in the spring is to really use that as an opportunity for control. You can see it builds up here in the fall, and then numbers start declining. And these are trap counts, but our assumption is they're running out of gas and they're dying. And in the spring, why not target those few that are in the landscape of those survivors that'll feed, lay eggs? And during that early winter spring activity, it's really, they do most of their feeding in the warmest part of the day. They need that strength, they need that warmth. And by the end of March to about mid-June, this is your window of opportunity. The guideline really is to start monitoring right around April 1st. You could push that, but you should first start seeing a lot of your low numbers, and particularly in cold areas, you may get a lot of zeros and then you'll get your first fly catch. I don't think there was a day here in Corvallis without a fly in a trap. There's also opportunity to perhaps target SWD who prepare for winter, and I'll explain that once we get to the approach in the fall. I do want to tell you that this is a trend, and I want to show you an example of why it's important to complement trapping with activity and prediction model. I want you to look here. I'm just going to show you a little bit from 2011, 2016, and we ran this model. And we're making some predictions, and you will see that the timing of egg laying varied from April 24th, actually, to July 4th, 1 to 4 weeks difference. So this is really a good warning in predicting when do they begin some of their crop egg laying, not non-crop, but the crop egg laying. So I thought I'd just run through, again, this is in spring. We got a lot of egg laying in some of the non-crop hosts, like honeysuckle, dogwood berries. I just discovered that a paper that talked about mistletoe, cherry and Portuguese laurel, elderberry. And they laid as early as late March in some of these, even these urban plants. And then I started looking in the trap activity that was going on in some of the commercial crops, like cherries. Can you see this little pupae? It's, again, the pupae that's within the fruit. We saw a substantial increase in late April. But I was looking closely, and the fruit was very small, very green, no coloring, no yellowing. And as I looked closer and got the trap activity, I was concerned about oviposition. No oviposition was taking place at this point. And I looked closely, and at the very end, as this leaf is stretching out and becoming a leaf, there's these extra flora nectaries, and lo and behold, who's feeding on them? They need that nourishment to help support the egg load. In complementing not only trap activity, we wanted to know, when are they laying? This is an incredible study. When are the females laying eggs? There's work being done. There's a paper that's being submitted. We took all these. This is a fly on her back. Look at the red eyes. Look at that serrated ovipositor, and went inside, and we were actually evaluating the maturity of the ovaries. Oh, a fun job, yes. Here's a set of ovaries, and with time, they develop. These dissected females, we could see when the eggs were maturing. Can you see the filaments? These are breathing tubes that you see the hair, these filaments coming out of fruit. Here's a very close-up of the eggs. And we found that they were most prominent, most mature, the egg, the ovary, in May in the Pacific Northwest. Very good information to know when your crops would soon be at risk. Knowing that they occurred in cherry, the question is, instead of broadcasting chemicals and increasing the risk of resistance, several researchers, including myself, are proposing to target that early season perimeters or early crop harvest before distribution into a whole landscape via, say, mass trapping. And I'm going to talk about that in Attract and Kill. And like this cherry block, where the SWD concentrated and are feeding early season. Perhaps this could be a citrus field in California. Very important, they're at low density, they haven't reproduced the great levels, and they're focused and concentrated in certain areas. Know where they are. This atracticidal sphere has an attractant inside. Work is being done on a big project, testing out these red balls, again, color red. They were used at one time for cabbage maggot control, or the possibility of bait stations. All of these are being tested. You need several years of testing to see the predictability of some of these bait stations in those high areas of SWD. There's a pretty good novel approach that are fluorescent red pouches that they're working on in Michigan. They're treated with insecticides, actually a reduced pesticide of, I think it was spinosad, and filled with attractants to lure and kill SWD in contact, placed early season within fruiting trees. There's some bait stations that were set up in shady habitats. This was done for tephridids, really the true fruit fly in Africa. You can imagine putting your bait in here. They come to feed on it, and lo and behold, they will die because it's laced with a pesticide. Perhaps using a very fine screen that only SWD can get in, 5/16 of an inch screen, to avoid other non-targets like honeybees or bigger, larger insects. So this attract and kill technology, mass trapping, is really on the horizon. There's something called Splat, where you could place this in various areas and be used to attract SWD and kill them. GF120 was really used for cherry fruit flies. So there's several pesticides that they're looking at, even a boric acid knockdown and a bait to draw them in and minimize their numbers out in the field. I thought this was a great study. This is something here, a cherry tree in which Bob Van Steenwyk was doing a little bit of work on, and others, and he used a reduced risk pesticide, that was a spinosad, and he used Suzuki bait, and he had significantly reduced SWD in the California cherry. So he's doing a little bit more work on this to confirm the success using less pesticide applications. So the bottom line is to really utilize this knowledge in your spring habitat. And can we treat some of the hot spots? Can we use bait sprays, trap them out, delay the ripening period? In this case here, there are a lot of Himalayan blackberry as well as wild cherry. These hot spots shifted. Late season, this was hot because this was persimmons, and they loved the rotting persimmons. This was elderberry. Started with wild cherry, elderberry, and then switched over to here. So a question I think a lot of people ask is, can we remove and replace these non-crop hosts of SWD? Well, I think as long as you know that they'll support some of the beneficials And also this refuge really becomes a good place to slow some of the pest resistance. So think thoughtfully. I wanted to show a backyard early season. This was in Oregon up north, and I got a lot of calls from this backyard person. And they told me, said, Amy, we have some Hascaps, Lanicera, and they were sampling with a bottle trap, and they had a little yellow card here because they were using that to spot some of the males. But figuring out innovative ideas, because this Hascap is early, and then their cherries come on, and then their blueberries, and once these get hit and you're not picking, you're not sanitizing your plants, some are dropping, it becomes a breeding ground. So I just threw out this idea. This is a screen, and it's used in greenhouses for thrips and aphids. I thought, why not a red one screen so it only takes in the very small critters, and trying to reduce early season when they're focused in on feeding the SWD. There's work being done. You can see here in New York, in which they are using a sap that I think was a mix of raspberry and wheat, and then this was impregnated with a pesticide that is organic. And they also they did some impregnation of some chemical, these, I call them, I guess, panels or banners, and to see how long that the pesticide can remain in the field. And SWD love these visual long vertical strips. It's both economical and environmental, and less of a broadcasting of pesticides. Again, knowing if this would affect other non-target organisms. So all in the study phase. Now we were talking about a lot of non-crop, and I mean, we have a list of berries that were maybe fall bearing and softened in the spring, and they're good oviposition hosts early season, as early as March. And so please refer to this publication online. You will see a list of hosts out there in the field that possibly that's your hotspot. A new one just came out in 2016 listing the host plants in Europe. Take a peek. So the big question of the day, and I know everybody asks this, can we capture enough flies with the abundance of traps to really minimize SWD if we're not using attract and kill or bait sprays? And it's been estimated that 5 meters, that trap density, 5 meters to 10 meters are, I think it was Cowles who predicted this, but it's really dependent on your attractant that you use and the radius of attractivity. Is that a word? Good question, huh? And the next question here is, how many do you put per acre? And in this case here, there was some work that was done in China. Wei Yang is from there, and you could see some bottle traps throughout the field using, again, some vinegar and sugar. And I wouldn't waste my whiskey here, but hey, and mixing that up and putting it into a bottle trap. And this was 100 traps per acre. Some were using 40 traps per hectare. That is 100 traps per acre, but also higher numbers from 150 to 200. I think it's guesswork at this point of not only the distance, but how many traps per acre, and all these were placed inside the crop. Interesting. So we thought, led by Richard Cowles, let's do a mass trapping experiment in the crop. An amazing amount of work. There was data that supported that 10 to 30% of the flies that landed on these cups didn't go inside. So we said, well, let's make this solution of 5% boric acid and sugar. They'll come to it, feed on the sugar, and we'll get rid of them, which is good. And let's trap 100 traps per acre using various baits that we thought were attracted that could compete perhaps with the fruit. In many cases, that's not the case. And across regions, east and west, I think it's at least 4, 5, 6 states. It was a low pressure year in 2014 and low damage. And there was no difference between whether we put these 50 million traps, it seemed like 50 million traps, to no traps. And we found that every trap plant had, in some cases, 5% more damage, although very low. Started questioning the idea of trapping inside the field. And in Spain, and also even for apple maggot in the 1995, they put traps all on the edge, 100 to 200 traps per acre, and found reductions of SWD. So I think this is really probably the way to go as far as research, and I back the perimeter trapping idea. There's some work being done in Spain where they're doing mass trapping and just reducing applications from, say, 4 to 2, and complementing the traps with less SWD. You probably have heard about using genetics to work against mosquitoes. Well, that is now the plan for SWD. I never thought we would come to the genetic piece just because there's so many out in the environment. But here, there's some folks working in North Carolina looking at the genes, and they produce abnormal genitalia. They start mixing with the wild populations, and some that are using that SIT radiation, sterilizing males, and then they copulate with the wild, reducing numbers in the field.
If you enjoyed this webinar and support this kind of work, check out our website and consider supporting us for future such efforts.